So multiplication is something we have to do quite often in nanotechnology, especially if we're working out sort of something, maybe a surface area of a nanostructure. So let's say, for example, we have a sheet of something like graphene, and give this some sort of lengths. Let's keep the numbers the same as last time. So we've got 1.5 micron along the length, and let's say that the breadth of it is 200 nanometers, and we wanted to work out the surface area of this. So we could convert everything to nanometers again, in which case you'll have 200 nanometers times by 1500 nanometers, and that's one way of being able to do this. Or we could try and do it in the scientific notation again. So what we're going to end up with is 1.5 times 10 to the minus 6 meters, because I've converted this into meters, times by 200, sorry, times 10 to the minus 9 meters. And what I'm going to do is just going to convert this, so it's 2 times 10 to the minus 7, so I can move my decimal points two places to the right, and that will convert that into a number which is 2 times 10 to the minus 7 meters. So this is all covered in a previous video of being able to convert these into different forms. So in my previous video I put together a list of mathematical rules for adding indices and multiplication of indices, and we said if we had x to the power a and we multiplied it by x to the power b, this is equal to x a plus b. So we're going to use that on this. So first of all, we're going to multiply these two numbers together. So this is 1.5 times 2, which is equal to 3. We're then going to use this figure here to work out what happens when we do times 10 to the minus 6 multiplied by times 10 to the minus 7. So when we do these two together, x is our 7, so we're going to end up with times 10, and then in the brackets we're going to have minus 6 plus minus 7. So I'm just going to put that in extra brackets. So we can do this bit of maths. So minus 6 plus minus 7, minus dominates here, so minus 6 minus 7 is minus 13. And because we're finding area and we're doing a multiplication, the unit of area is meters squared. So when we're considering these sort of problems, we always have to keep an eye on our units and what units we're going to. So what you can see is this number is very small. So if we were to write this out in terms of meters, we would have 12 or 13 zeros before the 3. So it becomes impractical to be able to write your numbers in terms of 0.000 something. It becomes much easier when we're doing it in this scientific notation. So sometimes in nanotechnology we have to calculate the volume of something. So let's take an example of a cube. Forgive my drawing on this, I'm not that great at drawing in 3D. But let's say this cube has dimensions of 5 nanometers by 5 nanometers and by 5 nanometers. So when we're calculating the volume, we have to times these three values together. So let's just give volume the symbol V, and we could do 5 nanometers multiplied by 5 nanometers multiplied by 5 nanometers, and therefore your volume is equal to 5 times 5, which is 25, times another 5, which is 125 nanometers cubed. So let's now consider this being written in a slightly different form. We could also have said that this is equal to 5 nanometers and the whole thing is cubed. And I will still give you this value. Now let's consider what happens if we had written this in scientific notation and we were looking at the volume in terms of meters. So we'd have to start this over here slightly. Volume is equal to 5 times 10 to the minus 9 multiplied by 5 times 10 to the minus 9 multiplied by 5 times 10 to the minus 9, which is obviously equal to 5 times 10 to the minus 9, and we're going to make that cubed because we've got 3 lots of the same thing being multiplied together. So again in the previous video we came up with a rule for this. So if we had a value of x to the power of a, that's meant to be an a, all to the power of b, we said that this was the same as x to the power a multiplied by b. So we can now apply this rule to here. So we are doing 5 to the power 3, which is equal to 125. We probably should just put the meters in here just to say that all this is in the units of meters. So we got 125. We're now going to use this. So the x is 10. So I'm going to put the 10 in. We're then doing a, which is the minus 9, times b, which is the 3. So 9 times, so the minus stays where it is because we've got a minus times a plus. 3 times 9, or 9 times 3, is 27. And then we've got the units, which is meters cubed. So these two are equivalent of each other. So before we said that 1 nanometer is equal to 1 times 10 to the minus 9 meters. So you get this conversion. However, when we look at volumes, what we're actually saying is 1 nanometer cubed is equal to 1 times 10 to the minus 27 meters cubed. So when working with volumes and multiplications of areas, volumes, you always have to be careful of what your units are doing, and therefore this also becomes important when looking at conversion between your scientific notations.